In this case, what will be the length of the string? And I'm exaggerating the displacements over here, up and down, but what will be the length of the string over here? Well, maybe it helps to do this. Half a period later is going to look like that. So this is, if you just look at one of the pictures, that's half a wavelength, that's another half a wavelength, so together this is one wavelength, and then half a wavelength. So half a wavelength, half a wavelength, half a wavelength, I have 3 half wavelengths. I can think of this as 1 times lambda over 2. I can think of this case as 2 times lambda over 2, and then 3 lambda over 2. And notice that the 1 here means like, 1 loop. The 2 here means I have 2 loops, if you want to call these loops. And then the 3 here means I have 3 loops. And I can draw a 4th one, a 5th, a 6th, a 7th. So I can see that in general, if I continue this, in general, the length of the string is some number, which could be 1, 2, 3, 4, 5, 6, 7, some number n times lambda over 2, where n can only take on which values? Well, in this case, right, the very first picture, n is 1. That's this 1 over here. In the second picture, the other possibility is that n equals 2. That's because of this 2, right? In the third picture, n is 3. Notice that the value of n corresponds to the number of loops also. So, therefore, where n can be 1, 2, 3, and so on. A positive integer. Not 0. I don't have an oscillation over here that corresponds to 0. If it's oscillating, then n cannot be 0. But these are the allowed values of this n. And therefore, I can take this expression, and I can write an expression for the wavelength in terms of L, which is 2L over n. But also, I know that the wavelength multiplied by the frequency is equal to the speed, right? Which means that the wavelength, or the frequency, I'm sorry, I'm trying to solve for the frequencies. The resonant frequencies will be the speed divided by the wavelength, and then I have an expression here for the wavelength, which I can then take and plug in here, so that the frequency will be the speed of this v is the speed of the waves going right, left, and reflecting at the end. And then the wavelength will be 2L over n, and therefore I can write the frequency as NB over 2L. And normally what you do is you say, well, the frequency of oscillation depends on the value of n. So you just put this as a subscript. And these are the resonant frequencies of the string. It means that if you disturb that string, and the frequency of the waves is one of these values, then you have relatively large amplitudes. So let's plug in some numbers. If n equals 1, then the frequency will be f of 1, and that will be 1 times v over 2L. By the way, this v is the speed of the waves in the string, right? This will be the speed of the transverse waves in the string, which is related to the tension in the string divided by the mass per unit length. Right? So mu is the mass per unit length of the string. It's what the mass is in kilograms if you just consider a length of 1 meter of that string. So, that really, that's the speed of the waves, right? So that goes in there. But anyway, I'll just write if I consider n equals 1, then f of 1 is v over 2L, right? If I consider n equals 2, then that will be called f of 2, because n is 2. and this would be 2V over 2L, which of course this is going to be V over L. But notice that F1 is V over 2L. So this is really, that's F1 right there in parentheses. So this is really twice F1. Right? If I say N equals 3, then the third frequency here will be 3 times V over 2L. But V over 2L is F1, so this is 3 times F1. So notice that if you just have one loop over here, if you have one loop over here, this string vibrates with only one loop like that, then that corresponds to the case when the frequency is the lowest. So the lowest frequency is called the fundamental frequency. It could have also been called the ground frequency, because the lowest you can be, is on the ground, right? So the lowest, that could have been called the ground frequency, but people tend to call it the fundamental frequency. Now, f of 2, notice, is an integer multiple of the fundamental frequency. It's 2 times the fundamental frequency. So because of the 2, this is called the second harmonic. A harmonic is defined as an integer multiple of the fundamental frequency. That's because of this 2 here. And then this one, notice this frequency, the one that corresponds to having 3 loops in the picture over there, this is 3 times the fundamental. So this is called the third harmonic. So the fundamental frequency is like the first floor of a building. The second harmonic is like the second floor. The third harmonic is like the third floor. Now, there's another way of describing these frequencies, not in terms of harmonics, but in terms of what people call overtones. So the fundamental frequency is the lowest frequency, and you can say that that's like the ground floor of a building. You could say that the second floor of a building is the first floor above the ground floor. So I don't know why you would do that, but So oftentimes the second harmonic is called the first. It's like the first frequency above the fundamental frequency. Like that. The first floor above the ground floor is the second floor. So this is called the first over, because it's the first frequency over the fundamental frequency. It's called the first overtone. So that frequency of twice the fundamental frequency can be described by 2 different names. Either the second harmonic, which is defined as an integer multiple of the fundamental frequency, or it could be described as the first overtone. Now, what else can you call the third floor of a building? What you would normally probably call the third floor of a building, you can call it the second floor above the first floor, right? So this would be the second overtone. So just be aware of that. And by the way, if you keep going like this and n is n, right? N equals just n, then f of n, right, would be nv over 2l, right, which will be n times f1. And this would be, well, it would be the nth harmonic. But therefore, it would be the what overtone? N minus 1, exactly. Okay. Fundamental frequency is the lowest frequency. Are we good? Actually, you've kind of been introduced to this. Well, yeah. When you learn about the hydrogen atom, and we will talk about the hydrogen atom later on, you think of a proton making up the nucleus of the atom, and an electron orbiting around the proton. And the electron has a mass, it's got a charge, it's so far away, right? And you can write down the energy. You don't call it mechanical energy, because yes, this thing has kinetic energy. The electron has kinetic energy as it goes around the proton, right? It's moving, so it's got kinetic energy. But the electron is also interacting with the proton, right? By way of two forces. They both have mass, so they both exert gravitational forces on one another. So you could add, if you like, plus gravitational potential energy, but that's very, very small compared to the other force of interaction between the proton and the electron. They're both positively charged particles, so they exert, in addition to gravitational forces, because they both have mass, they also exert electrical forces. And there is an energy associated with the electrical force, and it's called the electric potential energy. And that you don't neglect. It is